Hi, today I'm going to talk about the nth root of unity, and it follows that from De Moivre theorem that when z to the power of n is equal to 1, then the nth root of unity would be cos of 2k pi over n plus I sine of 2k pi over n, where k is equal to 0, 1, 2, 3 and so on with n minus 1. And in exponential form, these roots will take these forms. For example, 1 e to the 2 pi over ni, e to the 4 pi over ni, and so on. Now, we're going to try and solve this and try and see how this is going to translate into this. All right, so here we go. Find the sixth root of a unity. And I must add, okay, in exponential form. In their exponential form. Alright, so exponential form, that's what I'm talking about. Okay, z power 6 is equal to 1. The first root is already 1 because we've got z is equal to the sixth root of 1, which is 1. Now, for us to be able to get 1, k has got to be equal to 0. Why? Look, let the complex number be z1 is equal to cos of 0 plus 2k pi, so 2 times 0 pi, okay, over n, plus I, okay, sine of 0 plus 2 times 0 times pi over n. Now we know that n is equal to 6 over here, so let's put it as 6 if you want. Now, from here, we can clearly see that 0 times pi is 0, and 0 plus 0 is 0, 0 divided by 6 is 0. Cos of 0 from your calculator should give you 1. So we've got 1 plus sine of 0 here is 0, so that means it's equal to 1. So this is our first root. Now for the second one, let's move on to z2. z2, where k is going to be equal to 1. So now first I need to find the values of k. We did say that k is going to be equal to 0, 1, 2, 3 and so on, 4. In this particular case I've got 6, therefore it's got to be 5. Why? The last root is going to be n minus 1 from the formula. So from here, okay, I can say z2, which is then k is equal to 1. Alright, so we've already taken 0, I'm going to take 1. So I've got cos, no, not cos, let's put in the exponential form like this. So I've got e, alright, to the power of 2 times 1 is 1, and then times k is, times I times pi is pi, 2 over 6 to the 6i. So that means e to the pi over 3i. So that's my second root. The third root, z3, I've got e to the power of 2 times, there we go, so 2k, so 2 times 2 is 4. I've got 4 over 6, okay, pi I, and that turns out to be e to the power of 2 over 3 pi I. Second root. The third root is z4, e to the power of, now this time I've got 3, so 2 times 3 is 6, and I've got 6 over 6 pi I, and that turns out to be e to the pi I. Okay, so that's the angle, and from here, that's the third root, which, okay, so now we've got z5, which is then the fifth root is 4 here, k is equal to 4 for the fifth root, so e to the power of 2 times 4, which is 8, 8 over 6 pi, turns out to be I, then 4 over 3 pi I. And finally I've got z6, and k is 5, so I've got e to the power of 2 times 5 is 10, so I've got 10 over 6 pi I, turns out to be 5 over 3. So e 5 over 3 pi I. Okay. So, well, I guess that's it. That's about it. Alright, so what about this one here? I'm particularly interested in. We can leave it as such. This is pi, the angle is pi. So if I look at cos of 0 plus pi, so that should then be, isn't it, minus 1? So let's try and check out. So cos of pi turns out to be negative 1. Alright, that's great. So 2 times this and then 6. Okay, sine of 0 is 0. Alright, that's okay. So this one here can be written as negative 1. So these are roots. Alright, so z1, which is equal to 1. I've got 1, 2, 3, 4, 5, 6 of them. So this is much more like applying what we know from de Moivre theorem. I'm not trying to prove this, because if you try to prove this, you're going to go into further maths, so that's okay. I hope this helps. Take care.